Namaste students, welcome to statistics class, and we were discussing about standard deviation and coefficient of variation. Now, in case of standard deviation, we have solved the problem of the type of ungrouped data, and also we have seen the problems of group data. But in case of group, till now we solved the problems of discrete kind of data where we did not have class intervals. But today we will see how to solve the continuous series. And also you know that we are applying two kinds of formula. One is direct method and one more is deviation method. So we have seen direct and deviation method in case of discrete data, and also we have seen in case of ungrouped data. But today we will see direct and deviation method formula in case of continuous series, and with the same problem we will apply both the formulas, and we will see what kind of differences we get and what kind of answers we can find. Now firstly, if you observe the data, their heights and number of persons are given. Calculate standard deviation for the following frequency distribution. Now we write down the solution for grouped data, for grouped continuous data. Grouped continuous data. We will take the problems, that is class intervals and frequencies. Class intervals and frequencies. Class intervals are 155 to 160, 162, 165, 165 to 170, 172, 175, 175 to 180, 180 to 185, and last one 185 to 190. Then frequencies are 1, 6, 6, 6, 6 and 3 and 2. Now if you see what is the total number of frequencies, then we get total number of frequencies as 30. Now as I said, there are two methods, one is direct and one more is deviation method. Now firstly we will see the direct method. What do we get if we apply the direct method? So for continuous series, direct method formula is similar to discrete method formula, that is sigma fx square by n minus sigma fx by n whole square. There is no difference between discrete and continuous series formula with the direct method. We have same formulas for discrete and continuous with in case of direct method. Now sigma fx square by n. We have here class intervals and frequencies. So firstly we need to find out their x. So here x values are nothing but mid values. So 155 plus 160 divided by 2. When we do that, we get here mid value as 157.5. And here we get 160 plus 165 divided by 2. Then we get 162.5. And 165 plus 170 divided by 2. Here we get 167.5. Then 170 plus 175 divided by 2. We get there 172.5. 175 plus 180 divided by 2. Here we get 177.5. And here 180 plus 185 divided by 2. Here we get 182.5. And last one 185 plus 190 divided by 2. Here we get 187.5. So these are the x values or mid values. Now next we need to do according to the formula, that is fx. Then fx square. Now here fx, then f multiplied with x series. First one we get as 157.5 2.5 we get there 975. Then 6 into 167.5, there we get 1005. Then 6 into 172.5, there we get 1035. Then 6 into 177.5, there we get 1065. Then 3 into 182.5, there we get 547.5. And last one, 2 into 187.5, there we get 375. Now total the sigma fx. When we total it, here we get as 5160. This is of fx column. Next we have there f into x square. So there f into x square. That is nothing but we need to square this x column. Then we need to multiply with this x. Now these are the values. That is x square. See, in your textbook you don't have separate column for x square. They have showed fx square. So it is fx square it's not fx square, it is f into x square. It is not direct square of this particular column. Firstly you need to make the square of x, then you have to multiply with frequencies. So now first one, 157 into 157.5. The square of 157.5 you get there 24,806.25. Then the square of 162.5 you get there 26,406.25. So these are the square of these x values. So firstly when we need to do fx square, you write there f into x square. It is not fx square, f into x square. You need to square the values of x, then you have to multiply with frequencies. Now we will multiply this x square into frequencies. The first one 24,806.25 into 1, we get there 24,806.25. Then next one 6 into 26,406.25. So there we get 1,58,435.25. 1,58,437.5. Next one 160. Next one it is 28,056.25 into 6. And there you get 1,68,337. 1,68,337.5. Then next one 2,29,756.25 into 6. So there you get 1,78,537.5. The next one 31,506.25 into 6. So there you get 1,89,037.5. Then next one 3 into 33,306.5. There you get 99,918.5. 99,918.75. Then next one, the last one, that is 35,156.25 into 2. There you get 70,312.5. Now we need to total the fx square column. When we total it, we get there 8,89,387.5. This is about fx square column. See, here for the purpose, here we get bigger value. So you may do mistakes in between For that purpose, we are going with, when we have larger values, we are going with deviation method. So this is what, once we'll try with direct method, what answers you will get there. For that purpose, I have taken here direct method formulas. Now here apply into the formula. Sigma fx square we got as 8,89,387.5 divided by n value is 30 there, minus sigma fx 5,160 by 30 square. Now 8,89,387.5, when we divide it, we get there 29,646.25 minus 5,160 by 30 and square of that value, you get there 29,584. So here when you take the deviation, you get there 62.25 and you get final answer as the root of 62.25, you get there 7.89. This is the standard deviation of this particular problem when you have continuous series and when we have taken the formula of direct method. So now we'll see the same problem with the deviation method. What answers we get there? Now we'll solve that same problem with deviation method, class intervals and frequencies. 155 to 160, 162, 165, 165 to 170, 172, 175, 175 to 180, 182, 185, 185 to 190. We'll take the frequencies 1, 6, 6, 6, 6 and 3 and 2. And we know that n is equal to 30 here. So now in case of continuous frequency for ungrouped data, we write the formula deviation method is standard deviation is equal to sigma fu square by n, the root of sigma fu square by n minus sigma fu by n whole square. Now here firstly we need to find out, you know that firstly we need to find out here x column. Say there x we already found out in the previous method, that we get here 157.5 and here 162.5, 167.5 mid value, here 172.5 and here 177.5, 182.5 and here 187.5. Then next we need to find out their u, and here u is nothing but x minus a divided by c, means we have gap here. See in the formula we have that c into c, we have there into c. Now x value will take the first value, the least one, 157.5 as x here, sorry a 157.5. And what is the value of c? C means it is the gap. Gap is here 5. So how to find out u here? Here 157.5 minus 157.5 divided by 5. So there we get first one as 0. Next one 162.5 minus a value is 157.5 divided by 5. So there we get value as 1. The next one 167.5 minus 157.5 divided by 5. Here we get 172.5, that is the x, minus a. A is we have taken as 157.5 divided by c, that is the width 5. So here we get 3. Next one, 177.5 minus 157.5 divided by 5. Here we get 4. Next, 182.5 minus 157.5 divided by 5. We get here 5. And last one, 187.5 minus 157.5 divided by 5. Here we get 6. So here we got, now we got u. The next column which we need to prepare, that is f into u. 0 into 1. Here we get 0. Next here we get 6. 6 into 2. Here we get 12. And 6 into 3 we get here 18. 6 into 4 we get there 24. And next one, 5 into 3, 15. Here once again. So these are the values of f into u, and when we total it, sigma f u, we get as 87. So this is the value of sigma f. Now nextly we need to prepare the column f u square. So there also f u square means f into u square. So firstly we need to find out the values of u square. Here we got u as 0. So first one it is 0. Next we get 1. Here it is 4 and 9, 16, 25, and last one 36. So these are the u square. Now multiply u square with f. So first one we get here 0. Then we get 6 into 1. So 6 there, 6 into 4. Here we get 24. Next we get 6 into 9 there. So there we get 54. Then we get 6 into 16. There we get 96. Next 25 into 3. 75. Next 2 into 36. There we get 72. Now total this particular column, that is sigma fu square. So when we total it, here we get 327. Now substitute into the formula here. Sigma fu square we got as 327 by n value is 30 here, minus sigma fu as 87 divided by 30 into 5, the width of the class intervals. Now here 327 by 30 we get there 10.9 minus 87 by 30 square we get there 8.41 into 5. Now take the deviation, 10.9 minus 8.41, we get there 2.49 into 5. Now when you take the root of 2.49, we get there 1.5779 into, multiply with c, that is the width, that is 5 there. So here when you multiply you get there 7.89. You get a similar answer when you try it with direct method as well as deviation method. So when you have continuous series, it is better to go with continuous series also. You check the values there. If you have 10 to 20 and 20 to 30, 30 to 40, you can go with direct method, fx and fx square. But when you have values like 150, 160, it is better to go with deviation method, because when we try this formula with direct method, we get the larger values. It is difficult difficult to calculate. So when you have larger values here, in case of continuous series, it is better to go with deviation method. Or else, if it is a smaller values, you can go with the direct method. Now, in case of standard deviation, we have some other kind of problem, that is combined standard deviation, and you have one separate formula for that. You might have seen in case of arithmetic mean, there is one formula called combined arithmetic mean, where x bar c is equal to n into x bar 1, n2 into x bar 2 divided by n1 plus n2. So it's the continuation of that particular formula. So in this formula you have to use that formula itself. So here now we'll see what is that formula, and we'll see the problems under combined standard deviation. As I said, there is one topic called combined standard deviation. Combined standard deviation in case of standard deviation. And we have seen that is combined arithmetic mean when we were solving the problems of arithmetic mean. So here, this combined standard deviation formula goes like, it's the root of n1 into standard deviation 1 square plus d1 square. That is, d is nothing but deviation. Then plus n2, that is second observation, multiplied with standard deviation 2 square plus d2 square. So this is the formula of combined standard deviation, and where here we get first deviation d1 is equal to x bar 1, that is nothing but mean of the first observation, minus x bar c. X bar c is nothing but combined arithmetic mean, and d2 is equal to x bar 2, that is the mean arithmetic mean of second set of observation, then x bar c, combined arithmetic mean. How to find out this combined arithmetic mean? That is n1 into x bar 1 plus n2 into x bar 2 divided by n1 plus n2. See, here also we have n1 plus n2. So here combined standard deviation formula goes like n1 into standard deviation 1 square into plus deviation 1 square plus n2 into standard deviation 2 square plus d2 square divided by n1 plus n2. And here, how to find out? We know that this is the standard deviation and this is the number of observation in the first group. See, here we can clearly make out that here we get two sets of observation. So this is the sample number, the number of observation in the first set, number of observation in the second set, and standard deviation of first set and standard deviation of second set. And when we call it square, we can make it as a variance also. Maybe the variance of, if they give variance, directly we substitute the formula. If they give standard deviation, we have to make the square, then it will become variance. Then deviations. What is the deviations? Deviations is nothing but differences. Differences of what? Differences from their combined arithmetic mean. So here the mean of first set of observation minus combined arithmetic mean, we get the first deviation. The mean of second observation minus the combined arithmetic mean, we get the second deviation. So we need to apply the formula of combined arithmetic mean. There we get combined arithmetic mean. Then we need to find out the deviations. Firstly, we need to find out the mean of the set of observation. Then we need to take the deviation. Then the deviation we need to substitute to the formula. So this is the last formula in case of combined standard deviation. After solving combined standard deviation, we have last topic in case of standard deviation, that is coefficient of variations or C, where you get 10 marks questions from this particular topic. So in the next section we will see the combined arithmetic mean and then we will see coefficient of variation. Then we can move towards the